Ambar, you're not supposed to write anything on the screen. Okay, so in the last class we were doing this lesson number system, right? So 1 second. Yeah, so in the last class we were doing this lesson number system, and okay, yeah. Sorry, students, there was a little disturbance. So I was telling you how to create this spiral, and I also gave you this homework as well. Now I was checking the homework, but then you have drawn the spiral wrong, child. Just your spiral was a complete circle. See, this is a circle, and a spiral is somewhat like this. Okay, so whenever we are plotting the consecutive square roots, we get a spiral form, not a circle. What you are getting is a circle. You cannot get a circle. You have done something wrong, right? Just redraw it and submit it. And then, yeah, others assignments were fine. Okay, yeah, now let's move ahead to the next thing now. Umaima and Hafsa, put on your camera.
Yeah, okay, ma'am.
Yeah, put on your camera. Hafsa and Umaima. Okay, so I taught you decimal expansions as well. So we studied what kind of decimal expansions does irrational number have. So we know that irrational number will have a non-recurring and non-terminating kind of decimal expansion, right? Just know this thing. Next is, now we were doing few questions, right?
Yeah.
Okay, now children, there can be one more type of question. Let's come to this question. There's an example which says find an irrational number between 1 by 7 and 2 by 7. Okay, now if the question was find a rational number between 1 by 7 and 2 by 7, then what would have you done? Let's suppose the question is find two rational numbers. So the concept for rational number was, like, suppose it's written find two rational numbers. So what I will do, I will take the first number, multiply it with 2 by 2, I get 2 by 14. Then I take the second number, again I multiply with 2 by 2, I get 4 by 14. And my one rational number between 2 by 14 and 4 by 14 would have been 3 by 14. But this is the solution when the question was find an irrational number. You remember? But now the question says find an irrational number
Yes.
between the given two numbers. So what you will do is, now we know that irrational numbers are not in the form of p by q. You have to find the decimal expansion of
Ma'am,
1
your
by
voice is
7 and 2
breaking.
by 7. Right? So let's first find out
Ma'am.
the decimal expansions of 1 by 7 and 2 by 7. Okay. So what do I get first? 0.1. Is my voice lagging?
Yes, ma'am. Yes, ma'am. We can't hear your voice. Your voice is lagging.
Is it lagging for everybody?
No, ma'am, but I can hear your double voice.
Okay, my voice is echoing for Umema. And what about the others, Bidel and Hafsa?
Sometimes it's breaking, but we can still hear.
Umema, you put off your mic first of all, because when somebody's mic is off, then my voice echoes. Put off your
Okay.
mic. Yeah, now tell me, Umema, is my voice still echoing?
No, ma'am.
Is it still echoing? Is it fine now?
Yes, ma'am, it's fine.
Okay, and Bidel and Hafsa?
Yes, ma'am. It's fine. Now it's fine.
Amar, is it still breaking for you?
No, ma'am.
It's
Now
fine.
it's good. Now it's
Okay.
good.
Okay, now children, it's a very humble request that whenever I will tell you to put on your mic, please put on your mic only then, because otherwise my voice will echo for the other child. Okay, and Hafsa, please put on your camera quickly. Your camera is off. Yeah, so I was telling you, first of all, you're supposed to find the decimal expansion. So here I get, quickly do the division and find decimal expansions, everybody. And now see children, again I get 1. Again I get 1. So that means from here on my decimal expansion will repeat. That means I have this kind of decimal expansion. So what is my decimal expansion for 1 by 7? 1 by 7 is equals to 0.142857.
I'm a rejoin.
Who will rejoin? Hafsa. Okay, so this is my decimal expansion for 0.142857. Okay, now my next number was 2 by 7. So for 2 by 7, what will I get? One second. I don't know what's just happening. And see now again I got 2. That means again my decimal expansion will repeat. So for this number I have my decimal expansion is 285714. And a bar over it. What does this bar signify, children? This bar means that the decimal expansion from here onwards the number will repeat themselves. Okay, so that is the meaning of bar. Right, just quickly note down the and do till here first. Do the division part. Abdullah, do you hear me?
Yes, ma'am.
Yeah,
Yes, ma'am.
Abdullah, we are doing this question. Find an irrational number between 1 by 7 and 2 by 7. So we found out the decimal expansions first of 1 by 7 and 2 by 7. So do this much first of all.
Yes, ma'am.
Done, ma'am.
Okay. So now children focus here. Now you have these decimal expansions. Now I need to find an irrational number. So irrational number between 0.142857 and 0.285714. So see, it's very easy. First of all, you look at the first two numbers. So here I can consider, okay, 0.14 and 0.28. Now between 0.14 and 0.28, you see there are so many numbers: 0.15, 0.16, 0.17, 0.18, 0. So many numbers are there, right? So I will just, let's suppose I write 0.15, and now after 15 I can write as many numbers as I want according to myself. Just remember one thing, since the number I'm writing is an irrational number now. So the number, see, so I will write like 0, 1, 0, 0, 1, 0, 0, 0, 1, and so on. So I will write first of all 0.15, and after that I can write random numbers, but just remember the numbers should not repeat. Okay. So I want a decimal expansion that is non-recurring and non-terminating. It should not end and it is not repeating itself. Right. So now I get a irrational number. Now if the same question was find two irrational numbers, three irrational numbers, five irrational numbers, see, still we can find out. I can write 0.160110, 1110, 11110, any random numbers I'm writing after that. Then 0.17, 001, 0001, 0001, right? So I can write like this. Okay, children. So do this question like this. In this question, there was just one number asked to you. But even if they are asking you more than one number, so you can write them further as well. Did you understand this question?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, quickly do it.
Ma'am, is the division the division we have to do in the rough column?
Yes, children.
Ma'am, this division expansion we have to do in the rough column.
Yes, children. Is anybody asking something?
I'm asking if this division expansion we have to do in the rough column or like in the exam paper.
Done.
Yeah, was anybody asking something?
Ma'am.
Children, am I audible?
Yeah.
Yes, ma'am.
Yeah, was anybody asking me something?
Yes, ma'am. I was asking that the division expansion in the exam paper we have to do it the rough column or like that is the
Now,
step.
see, remember that depends on the way your school teacher is teaching you, because she is going to check your paper. So, if she has she taught you to do it in the rough column or in the fair notebook only?
She told me to do it in the rough column.
So you can do it in the rough column. She's because she is the one who's going to check your papers. So you should do this thing according to her.
Okay, ma'am.
Okay. So children, now we come to the next question. I'll give you a similar type of question. Now you'll do that on your own. So find three different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Okay, so these are the two rational numbers that I'm giving you, and now you have to find out three different irrational numbers between these numbers. So you will follow the same method. Find the decimal expansions first of all, and then you write the numbers between them in irrational form. Do it quickly. Did anybody found out the answer?
No, ma'am.
Did anybody find out the decimal expansions of 5 by 7 and 9 by 11?
Ma'am, I
You can
found
tell me
for
the decimal.
5 by 7.
Yes,
Yeah,
ma'am. I
Abdullah
found
found.
it.
Okay, tell me the answer, Abdullah, for 5 by 7. What's the decimal expansion?
0.714287.
And it's repeating itself.
Yes, ma'am.
Yes, ma'am.
So it must be repeating only till 5. So only this much you will see. And for 9 by 11, for 9 by 11,
For
Ma'am,
9
I'm
by 11,
finding.
it is 0.8.
0.09. 0.09.
no, 0.09 is incorrect. Yes,
Ma'am,
Umema?
0.81.
0.81. Yeah. So, and that's repeating. So now what happens, if you have to find out various different numbers, so you will say, ma'am, how can I write down? Because between 7 and 8, there are no numbers. But children, if you see, if you take 71 and 81, now you can find out various numbers. Right, so I can write down 0.72 and then write numbers randomly 0, 1, 0, 0, 1, 0, 0, 0, 1 and so on. 0.73, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1 and so on, and 0.74, 0, 1, 0, 0, 1 and just random numbers according to this. Okay, so you can do it like this. Yeah, children, now the next question is, now it is given to you, we know 1 by 7 is equal to 0.142857. Can you predict what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actual division? Okay, now what happens over here? Now children, you see that how do we get 2 by 7? We know 2 by 7 we actually get by multiplying 2 into 1 by 7. Right? So we know 2 into, now what is the decimal expansion of 1 by 7? 0.142857 bar. So this will become, you just multiply this 2 with this decimal expansion and put a bar over it. So the decimal expansion of 2 by 7 is this number. And how did I got it? I first converted 2 by 7 as 2 into 7 and then I'm multiplying it with the decimal expansion. Similarly, how will you write the decimal expansion of 3 by 7? You can break it down into 3 into 1 by 7. and you get 3 into 0.142857 bar, and now you multiply it to get your answer. Okay, and similarly for 4 by 7 also, 5 by 7 also, you can find out like this, right children? So do this
Yes,
also.
ma'am.
Just write down
Yes, ma'am.
this for 2 by 7 you write down so that you remember, and the remaining thing you can do afterwards. Then I'll move to the next question. Just write down for one question.
Done.
Done, ma'am.
Ma'am, done.
Fine, so we move ahead now. It says, okay, an interesting question now. Express 0.9999 in the form of P by Q. Yeah, you find out this much first. We studied these type of questions before also, right? So try to find out the answer for this and tell me the answer.
Ma'am, I got the answer as 1.
Yeah. Who got as 1?
Ma'am,
Oh, Mema,
Me.
yeah, very good, Mema. If you're getting 1, tell me your solution. Now, everybody listen carefully.
I wrote let x equals to 0.999
Yeah, okay.
and then 10x equals to 9.999 and then
So, first
equation
you write
1.
down let x equals to 0.999 and so on. Then, okay, children, now we know that 0.9999 can actually be written as 0.9 bar. So, we know bar is on one number and that is the first number only after decimal. So, we will take 10x now, right? So, 10x is equals to 9.9999. Next.
Next, then equation 2 will be subtracted from equation 1 and then we'll get 9x.
Equation 1, this is equation 2. Thus,
Yeah.
subtracting equation 1 from 2, what do we get? 9x is equals to 9 and thus x is equals to 1. Is everybody getting the same answer?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Others within What about Bidel?
Yes, ma'am.
Okay, fine. So children, now you get to see that your answer is 1. Now, can you tell me, is 1 a rational number or not?
Yes, ma'am.
Yes.
Yes, ma'am.
Yeah, is
Yes,
1
it
a
is.
Yes,
rational
ma'am.
number or not?
Yes,
Yes.
yes.
Okay, fine. So what happens over here? So this was only the question that you have to represent it in the form of a rational number. So we know 1 is also a rational number. Thus, we are getting 1. That's correct. Now next question, children. Okay, classify the following as rational or irrational. Root 23, root 225, 0.3796, 7.478478, 1.10, 1001, 0001. Yeah.
Ma'am, we have done this as an assignment.
Yes, ma'am. We have done assignment.
You have given this assignment to us.
Okay, I did give this for assignment. So no problem, we can discuss it. Even the assignment questions are to be discussed, right? So what about the first one, children? Do you think it's an rational or irrational number?
It's
Irrational.
rational.
Irrational.
Irrational number.
Right,
Irrational.
this is irrational. Then second one,
Rational.
rational. Why
Because
is
of
it
15.
Because it can be written as
15 number.
15.
15? Yeah. Amar, I'll give you chance, okay? I'll ask one by one, students.
Okay.
Then you can answer. Now third one, Hafsa will tell me. Hafsa, is this rational or irrational?
Irrational.
Rational. Why is it rational?
I said irrational.
So why is it irrational?
Is it?
Why is it irrational?
Um,
See, I told you irrational numbers have recurring, non-recurring and non-recurring and non-terminating decimal expansions. But this has a terminating decimal expansion, so that is why it's rational, not irrational. Okay, sir. I can write it in the form of p by q. Then fourth one, Vidal, tell me. Now, Vidal, is it rational or irrational? The fourth one.
it's rational
Why is it rational?
because it's rational because it's repeating, not terminating.
It's repeating. Okay, first of all, it's repeating. Then secondly, it's also terminating. So recurring as well as terminating. So that is why it's rational. Then next fifth one, Abdullah will tell me.
Ma'am, it's irrational.
It's irrational. Why irrational?
Ma'am, because it's continue. It's not continuing, but
Because it is. Yeah,
ma'am,
Abdullah.
because non-repeating and it's non-terminating.
Yeah,
Because
it's non-recurring as well as non-terminating. That is why it's irrational. Good. Now, next question is. Okay, that's it for this exercise. Yeah, children. Now we come to operations on real numbers. Just give me 1 minute, children, then we'll start. One second. The question is, real numbers. Okay, just a quick question, children. What are real numbers? What are real numbers?
Ma'am, they consist of rational and irrational numbers.
Can anybody tell me what are real numbers?
Ma'am, they consist of
A
rational
collection
and
of
irrational.
rational and irrational.
Rational as well as irrational numbers together constitute real numbers, right? So in this section, we are going to talk about all the expressions between the rational as well as irrational numbers. So the first question is, check whether or no, let's do this question. Add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. Okay? What you have to do over here is you have to add, this is one of the number and this is the other number, and now you have to add them. So children, how do we perform operations on rational and irrational numbers? See very carefully. First of all, whenever you're going to have under root numbers, okay, let's first look at this. Let's suppose I have root 2 and I say plus 3 root 2. Okay, so what happens? Do these numbers have similar root? Like when we have a same root number. Yeah, this also has a root 2 number and this also has a root 2 number. That is why I can add them. Can I add root 3? Can I add 2 root 3 plus 4 root 3 or 4 root 2? Can I add these numbers? No.
No.
They cannot be added. Why they cannot be added? Because they have different root numbers. The root is not on the same number, so they cannot be added. But these numbers I can add. So first of all, you need to make a distinction between what numbers you can add and what numbers you cannot add or subtract. Now root 2 plus root 3, how are you supposed to add? First of all, you are only going to add the coefficient. So what is the coefficient of root 2? What is the coefficient? Over here in the first case.
3, 3,
In
One.
the first case, 1.
One.
It's 1.
1,
And what is the coefficient of root 2 in the second case?
3.
3. So 1 plus 3 you will do. And now root 2 is here also, root 2 is here as well. So you take root 2 as common number. Okay, you will not write root 2 plus root 2 now. You have already added the coefficient. And now your answer becomes 4 under root 2. So this is the general form of how you are going to add or subtract the numbers. You only add or subtract the coefficient. That's it. Right? And the coefficient of only similar kind of roots. If you have different kinds of root numbers, then you cannot add or subtract the coefficient. Now next is this question. So look here. Now you have, first of all, you open this bracket. You are adding them. So I will write 2 root 2 plus 5 root 3 plus root 2 and minus 3 root 3. Right? I opened it. So you're not paying attention to the class. Where are you looking at, child? Hafsa, are you there?
Yeah.
Hafsa, are you listening?
Yes, ma'am.
You seem to be so lost. So children, now you can add down 2 root 2 and root 2. So this becomes 2 plus 1 and then root 2 you put. And now you can add, you can solve 5 root 3 and 3 root 3 together. So this becomes plus 5 and minus 3 root 3. Right? So this part will become 3 root 2 and this part will become 2 root 3. So this is our answer.
how?
Amar didn't understand.
Yes, ma'am. 2 root 2 plus 5 root 3.
Look here. Amar, what are the root numbers over here? in the first, second, third and fourth terms. Here my root number is root 2, here it's root 3, here it's root 2 and here it's root 3. So I can
Yes.
only solve these two numbers and these two numbers together, right?
Yes.
Only
Okay.
similar. So first of all you bring them together. So 2 root 2 plus root 2 you write together, and plus 5 root 3 and minus 3 root 3 you write together. Okay. Now 2 root 2 plus root 2 is how much? 2 plus 1 and then root 2. The coefficient of root 2 is 1, right? And this
Yeah.
becomes
+1.
plus sign and then 5 minus 3 root 3. So this part becomes 3 root 2 and plus 2 root 3. Now
Yes,
you
ma'am. Okay.
understand.
Now
Okay,
I
so
understood.
quickly. Abdullah, your camera is off. Yeah, everybody understood this question?
Yes, ma'am.
Yes, ma'am.
Quickly copy it, then I'll move to the next one. Abdullah, why is your camera off?
Done, ma'am.
Done, ma'am.
Done, ma'am.
Okay, fine. So now children, next question is multiply.
Ma'am, could you scroll back up?
Yeah, Hafsa.
Yeah, I'm done.
Okay, now the question is multiply 6 root 5 by 2 root 5. Now children, how are we supposed to multiply them? See, in multiplication, this rule is not followed, that you can only solve similar kind of root numbers together. You can also solve dissimilar roots together. But by chance the question here is for root 5 and root 5 only. So what I will do is, first of all, you will multiply all the terms with the other terms. So the coefficients you will multiply with the coefficients and the root numbers you will multiply with the root numbers. In addition and subtraction, we were not doing anything with the root number. We were just writing it as it is. But here you will multiply both the root number together. So this, what is the coefficient of root 5 in the first place? It's 6. Multiply. What is the coefficient over here? It's 2. And then multiplied with root 5 into root 5. Okay. So you solve everything together.
Yes.
And now 6 into 2 is 10, 12 into root 5 into root 5 is how much?
Root 25. No, 5. It's 5. It's 5.
Yeah, it's 5. Children, whenever we have two same numbers, two same root numbers, so what you will do, you will remove the root and then write your answer. Like root 2 into root 2 is how much? 2. Root 3 into root 3 is how much? 3. Root 4 into root 4 is 4. Like that, root 5 into root 5 is 5. And now 12 into 5 becomes 60 as your answer. Okay, children, that is how you do. Now, even if I have numbers like this, 2 root 3 multiplied with 4 root 5, even this number I can solve. How will I solve it? 2 into 4 into root 3 into root 5. Okay, so what does it become? 8 into, now what is root 3 into root 5? What is 3 into 5? 15.
15.
So root 3 into root 5 is root 15. So your answer becomes 8 root 15. Right, children?
Yes, ma'am. Easy only.
Now next question says divide 8 root 15 by 2 root 3. Now again children, what you will do over here, you write down 8 under root 15 divided by 2 under root 3. So children, here also you solve the coefficient with the coefficient. Can you cancel 2 and 8? Yes. 2 into 1 time is 2. 2 into 4 time is 8. Right. Now, can 15 and 3 be cancelled? Yes, I can cancel it. 3 into 1 is 3, 3 into 5 is 15. But children, remember one thing, you will not write it like this. Okay, do not put these cut signs in your notebook. For root numbers, you can put these cut signs for coefficient, that's fine. But for root numbers, do not put these cut signs. It will be considered wrong. Okay, I am just telling you, I'm just illustrating over here to explain it. Do not write it like this in your notebook. Just know it in your mind. Okay, 3 into 1 is 3, 3 into 5 is 15. You can do it in rough. And then your answer will be 4 root 5. Okay. See, you can even do it like this. 8 root 15 by 2 root 3. So can I break root 15 as root 5 into root 3? I can write root 15 as root 5 into root 3 into 2 into root 3, and root 3 is cancelled. 2 and 4 is cancelled. 2 and 8 is cancelled, and you get root 4 root 5. Even this is one of the method by which you can solve. Yeah, solve this children. Copy it quickly.
Finish, ma'am.
I'm not done, ma'am. I'm done.
Ma'am, you're on mute. Ma'am, you are on mute.
Oh, I was on mute. Okay. So children, now the question is simplify the following expression. So the first question is 5 plus root 7 into 2 plus root 5. Okay, and now how am I supposed to solve this? Look here. Children, we know that whenever we are multiplying the did I teach you binomials into binomials? Yeah, the last chapter we did this one only, right? Polynomials we were doing. So children, do you remember that how we used to solve them whenever we were solving a binomial into a binomial? So we used to take the first number, multiply it with both the numbers, then we used to take the second number, then again multiply with both the numbers. So we will follow the same pattern over here. You take the first number, multiply it with 2 first, again take the first number, multiply it with root 5. Now you take the second number, multiply it with the first number, again you take the second number, again you multiply it with the second number. Okay, you can even write first statement like this: 5 into 2 plus root 5, then plus root 7 into 2 plus root 5. And then you can, this can be the first point, this can be the second point. And now you can solve it. So 5 into 2 is 10 plus 5 root 5 plus 2 root 7 plus 5, it was of 15, yeah, 35. Okay, can I solve anything further? No. So this remains as it is. This is your answer. Okay.
Ma'am, can you explain again?
Yeah,
Because
sure.
5 into 2, 10. Then plus 5 root 5. Then how you got plus 7 root 2?
Root
Can't
7
we write
into
14 by 7? 14 root 7 can't we write 14 root 7?
by 14 root 7, Amma.
7 multiplied by 2, then 14 root 7, no?
No. If you're even multiplying 7 with 2, still you won't get 14 root 7. But see child, what we do here is, we multiply the coefficient with the number, right? We can only multiply rational numbers with rational numbers, irrational number with irrational numbers. So the coefficient of root 7 is 1, so you multiply 1 with 2 and then you get 2 root 7. Okay? You
Okay, ma'am.
write the number outside. Root 7 into 2 is 2 root 7. Now root 7 into root 5 is root 35. Why? Because there is a root on both the numbers.
Okay, ma'am.
Okay, shall I move ahead now? Next question is 5 plus root 5, 5 minus root 5. Now, who will tell me what identity are we using here? Does this resemble any identity? Or no?
A plus B, A minus
Distributed.
Very
A
good.
square.
A plus B, A minus B. So try solving it on your own once with the identity A plus B, A minus B.
A plus B, A minus.
Finish, ma'am.
Done now.
Ma'am,
What answers are you getting?
Ma'am, I got 20.
20.
I got 20.
Everybody got 20. Let's check.
Yes, ma'am.
So A plus B, A minus B, what is A over here? 5. What is B over here? Root 5. So we know A plus B, A minus B is A square minus B square. So what's A square? 5 square minus root 5 square. Right? That gives you 25 minus 5 and your answer is 20. Right? Now the next question is root 3 plus root 7 whole square. So now which identity do we have to use here?
A plus B whole square.
A plus B whole square. So that counts for A square plus B square plus 2AB. So root 3 square plus root 7 square plus 2 root 3 into root 7. So you get 3 plus 7 plus 2, 21, and plus 2 root 21. Right? Now, children, there is one more thing to it. See, whenever you have these root numbers, so you don't have to write, you can even miss this step very easily. Because you know, now whenever both the root numbers are there, so can I write down an identity for these kind of numbers? It becomes root A plus root B whole square. This is my new identity that I'm writing, just a variation. So can I open it up as A plus 2 root AB plus B? Can I directly open it up like this? See, this is my answer, right? A, what's A now? 3. So you can directly write 3 plus 7 plus 2 into 3 into 7, that's 2 root 21. So I can directly write the answer like this also. Even when it's root A minus root B whole square. So still I can get my answer as A plus B minus 2 root AB. Okay, so whenever you have root numbers, you can just remember this identity. You can even note these identities down.